Okay, very good morning, one and all. Now we are going to discuss the topic of vending machine model. We are going to design. Okay, we are going to design a model of vending machine with the concept of sequential circuit by giving the inputs x and y, where x is 5 rupee and y is 10 rupee to get the outputs a and b, where a is 5 rupee chocolate and b is a 10 rupee chocolate. So also the conditions were given. If you put 5 rupee coin, you can get 5 rupee chocolate. If you put 10 rupee coin, you can get 10 rupee chocolate. But the one more condition is if you put two 5 rupee coin, you can get 10 rupee chocolate, right? So after putting one 5 rupee coin, it has to wait for some time. Then only it has to dispense the chocolates, right? So for this scenario, we have to draw the state diagram as well as the state table. Okay. So before proceeding with this, let us clearly write what was the inputs. I mean, this x is nothing but y is nothing but then as well as a as well as b. So just for our understanding, right? What is x? These things are inputs. So as per the given statement, these are the inputs x and y. So this x is 5 rupee coin, y is 10 rupee coin, a is 5 rupee chocolate, b is 10 rupee chocolate, right? So also the conditions was given. So if you put two 5 rupee coin, we can get 10 rupee chocolate. So for 5 rupees coin, you can get 5 rupee chocolate. For 10 rupees coin, you can get 10 rupee chocolate. For two 5 rupee coin, the machine has to dispense a 10 rupee chocolate. So it's a very important condition that should be noted, right? So for that, let us see how we are going to analyze the state diagram. So we have two inputs. Let us have four states then. So initially I'm assigning the state as S0 with the initial conditions, that is it's nothing but an inputs. So this x and y is nothing but the inputs that was mentioned at the mentioned as 0 0. Okay. So this is the initial state. So I won't get any output here. So the output is 0 0. Right. Next, I'm giving one 5 rupee coin. I'm inserting one 5 rupee coin. Then the state is moved to next state, that is we can call it as an S1. If you put only one 5 rupee coin, it will not dispense chocolate. But the thing is, it has to dispense 5 rupee chocolate, isn't it? But it has to wait for the second coin entry. If it was not done, then it has to be dispensed. So no outputs. So you won't have any chocolates when your input is 1 0. That is, this represents 5 rupee, this represents 10 rupee. Okay. So I'm not inserting 10 rupee, I'm inserting just only one 5 rupee coin. At that time, it will not, machine does not dispense any chocolates, right? Next, if I am inserting, or let us consider the second case. I am not now insert any coin, which means no input was given, right? So at this stage, first I'm inserting one 5 rupee coin. It moves to S1 state. Then I'm not inserting any coin. Then it moves to the state S2 at the time. So time gets expired. So it has to dispense one 5 rupee chocolate, right? So this one represents output. So one 5 rupee chocolate gets dispensed at this stage. Hope you all got this, right? I'll repeat. First, initially, this S0 is nothing but an initial stage, that is at the reset stage. At this stage, I am inserting one 5 rupee coin. Only one 5 rupee coin I am inserted. This one represents, this is just for your understanding, 5 rupee coin was inserted. It will not dispense chocolate immediately. At sometimes, after some time, so no coin was inserted. So then this S1 state will move to S2 state. At this time, it will dispense one 5 rupee chocolate. Suppose in this stage, at this stage, if I insert one more 5 rupee coin, then this will reply with one 10 rupee chocolate, right? Isn't it? So one 10 rupee chocolate has to be dispensed when after this stage, it one more 5 rupee coin gets inserted. Okay, got it? Great. So one more condition was not specified in the question. The one more condition is if any extra coins were inserted, let it be of for the first time if you are inserting 5 rupee, then the second time if you are inserting 10 rupee coin, at that time it will dispense only a 10 rupee chocolate and it will not return any coin or any chocolates. So suppose if I am inserting first 5 rupee, right? So first 5 rupee coin was inserted. At the second time period, I am inserting 10 rupee coin. So the machine will dispense only 10 rupee chocolates. So this 5 rupee will not be returned by the machine. So 5 rupee will not be returned. Okay, that was the scenario. That was the design which was given. Okay, so come back to the design state diagram. Okay, now at this stage, so one 5 rupee was inserted, no 5 rupee was inserted, can dispense one 10 rupee chocolate. At this state, that is S1 state, only one 5 rupee coin was inserted. Now at this stage, if I am inserting a 10 rupee coin, that be of 0 1. So this 1 represents 10 rupee coin. It has to dispense only one 10 rupee chocolate. It will not dispense the 5 rupee coin. I mean the additional amount, it will not be gets refunded. Okay, that was mentioned here as 0 1, but it will dispense only 10 rupee chocolate, right? Next thing, so at this stage, right, it will be the machine has dispensed a 5 rupee chocolate here. So at this stage, if I'm inserting one 5 rupee coin again, right? If at this stage, that is after dispensing a 5 rupee chocolate, if I'm inserting one 5 rupee coin, then it moves to the previous state, that is S1 state, right? At this state, if the second time I'm inserting a 5 rupee coin, then this will dispense the 10 rupee chocolate, right? If suppose I'm at this stage, so after inserting one 5 rupee coin, it moves to the S1 state. Then at this state, if I'm inserting a 10 rupee coin, then the machine will dispense a 10 rupee chocolate, right? Then suppose if I am at this stage, so 1 0, that is 1 5 rupee was inserted, right? Suppose I'm inserting now one 10 rupee chocolate at this, I mean 10 rupee coin at this stage. So 10 rupee coin 0 1, right? The machine has to dispense one 10 rupee chocolate, right? If suppose I'm inserting both 5 rupees as well as 10 rupee coin, then the machine has to dispense only the maximum possible is 10 rupee chocolate. Okay, so hope we'll understand this. Then we had a 0 1. Suppose at this stage, if I'm inserting both 5 rupee as well as 10 rupee coin, the machine has to dispense the maximum possibility of 10 rupee chocolate, right? Keep in mind the first one represents 5 rupee coin, this represents 10 rupee coin. So this one represents the outputs. Okay, right. So all the possibilities are written, right? So 0 1 1 0 as well as 1 1 was written. So here 0 0 1 0 was written. Okay. Now the machine has dispensed a 10 rupees chocolate here. Suppose if I am inserting one 5 rupee chocolate, sorry, one 5 rupee coin. If at state if the machine is at S3 state, that is after dispensing 10 rupee chocolate, suppose if one 5 rupee chocolate, sorry, if one 10 rupee chocolate was inserted at this stage, it will dispense one 10 rupee chocolate. Suppose if I am inserting both 5 rupee as well as 10 rupee, so at that time also the machine gets dispensed only 10 rupee chocolate. Right. Now comes to the first initial state. If at this initial state, if I am inserting a 10 rupee coin, the machine has to dispense a 10 rupee chocolate. That is, this S0 will be moved to S3 state. That is that it has to dispense a 10 rupee chocolate. Right. Suppose if at this stage I am using both 5 rupee as well as 10 rupee coin, the machine has to dispense only 10 rupee chocolates. Right. Now at this stage, if it was no coin was inserted, it will move to the initial state, that is a reset state. Right. So this is our state table. So keep in mind, whatever input you are giving, the machine has to act accordingly. The first condition which was given is, if I'm using a 5 rupee coin, the machine has to dispense a 5 rupee chocolate. If I'm using 10 rupee coin, machine has to dispense 10 rupee chocolate. If the other case, if I'm using both 5 rupees coin, I mean two 5 rupees coin, so the machine has to dispense a 10 rupee chocolate. In case if I am using both 5 rupee as well as 10 rupee coin, then the machine has to dispense the maximum possibility is 10 rupee chocolate. The remaining 5 rupee coin or chocolate cannot be dispensed. Okay, this is the truth table of the given. Okay, after obtaining this uh, state table, we'll write this state. Sorry, after obtaining this state diagram, we'll write the state table. So state table, the first one is actually present state. So present state. Then next state. Here we will try to implement. So this should be of input, right? Present state. Then input. What is the input for our case? It is a 5 rupee coin as well as 10 rupee coin. Then this will be of next state. And the other thing will be of output. Will be that is what is the output here? In our case, it is 5 rupee chocolate as well as 10 rupee chocolate. So present next state. Let us here also it was not mentioned what type of flip flop to be used. So we can use D flip flop for our convenience. Next state D1 plus, since we are having a 4 states, right? So hence I'm using two flip flops. So input is X and then Y. Present state is D1 as well as D0. So I'm writing the possible combination 0 0 0 0 0 1 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 1 0 0 1 1. So here I missed one more value. So 1 0. Here the value is So it's 101, 110, 111. So 1000, 1001, 1010, 1011, 1100, 1101, 1110, and 1111. Right. So these are the maximum possible combination of present state along with the inputs. That is 5 rupee coin as well as 10 rupee coin. Then the next state can be analyzed here with the help of the state diagram. When both the inputs are 0. Now we can go back to the state diagram. When both the inputs are 0, when both the inputs are 0, what was the output? The output is also 0. Got it? So the output here is 0, 0. Next, compare. My input is now 0, 1. Present state is 0, 0. Go back to state diagram. My present state, my input is 0, 1. The present state is, my present input is 0, 1. And my present state is 0, 0. What was the output? The output is, so when my input is 0, 1, when my input is 0, 1, my present state is 0, 0. Okay, let us complete the truth table, sorry, state table. So here, before that, you just mentioned here. So I'm assigning some states numbers here. Let it be of, so we are having states, right? So S0 will be considered as 0, 0. S1 will be considered as 0, 1. And S2 will be considered as 1, 0. And S3 will be considered as 1, 1. Right? From this, now we can write here. So this is actually, now look at here. This is actually an S0. Right? When the input is 0, 1. Now look, go back to this. This is S0. It is 0, 0. When my input is 0, 1, where it goes? My input is 0, 1, it goes to S3 state. The corresponding S3 state when value is 1, 1. Hence I'm writing the next state as 1, 1. And in some cases, you can write here S3. This will be of S0. Similarly, this will be of S0. When 1, 0 is giving, let us analyze from the state table how it is in S0 when 1, 0 is giving. At this stage, when 1, 0 is giving, it moves to S1 state. The S1 state value is 0, 1. Right? Now write here as 0, 1. This is nothing but an S1 state. Right? Similarly, I have to compare this with all the things. I'll tell for one more thing. For S0 state, when both the inputs are high, that is at this stage, when 1, 1 is giving, it moves to S3 state. S3 state, the value is 1, 1. So 1, 1 is actually an S3. This is again S0. So here you can note it down. So this all values will be of S0. So this inputs are S0. This is not in present state. S1. These are S2. Last will be of S3. Right. This is about when this input is given, what is your output. Right. If this was the case, when we are checking, so 0, 1, 0, 0, I will get, let us analyze from the state table. That is from S1 state when 0, 0 is giving. So S1 state when 0, 0 is giving, it moves to S2. S2 state value is 1, 0. Right here, 1, 0. When the same state when 0, 1 is given. So 0, 1 is given, it moves to S3 state. So it is 1, 1. So 0, 1, 1, 0 is giving. So 1, 0 is given, it moves to, at this state, when 1, 0 is given as input, it moves to S3 state. So S3 value is 1, 1. Similarly, you have to complete the entire table, right? Okay, in a similar way, you complete the next state value. So that is for S3, you are going to compare with these four inputs. What was the next state, right? Now we are going to analyze the output part. The same thing that you are going to consider. So S0 state, this is the S0 state. When my input is 0, 0, what will be the output? So output here is AB. A represents 5 rupee, B represents 10 rupee chocolate. So no chocolate was disseminated at this stage, right? So this will be of 0, 0. So okay. So this will be of 0, 0. Next, so my present state is 0, 0 and my input is 0, 1. What will be the output? The output is still 0, 0. So in a similar way, you can write all the outputs, right? 0, 0, all the things 0, 0. You can check with the state table. In a similar way, you just complete. In a similar way, you can complete the entire output table. That's all about the state diagram as well as state table. So if you want to proceed further, then we have to go for a K map and come and analyze what was the output. So for D1 plus as well as D0 plus next state can be analyzed, right? So what was the thing? Then from this inputs, so D1 D0 as inputs with the help of D1 D0 as well as XY. For K map, this will be considered as a 4 variable K map for D1 plus. Let us give an idea. For D1 plus, the K map can be computed. For D0 plus, that is the next state. Have to compute the K map for 4 variable K map, right? So A, but this was not given, not asked in the question. But anyway, the next step, in case if in exams if they ask, can proceed with this. So D1 D0 XY. So 0 0 0 1 1 0 1 1 0 0 0 1 1 0. In a similar way, just fill all this D1 plus values and then find the K map and then execute in implement it implement the given expression in the logic circuit, right? That's all about the implementation, but this was not asked in the question. If you want to, students, please try with this, get some additional experience of drawing the implementation, logic implementation. Okay, thank you all.